Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to do a topic in mathematics, and that is the integrals of exponential functions. We're going to see that exponential functions have some specific ways in which they are being treated so far as integration is concerned. And we're going to look at two basic rules, that's the simple exponential rule and the general exponential rule that we're going to apply in doing some of the problems that we're going to use for our demonstration for today. So that is basically what we are going to do in this topic. And I'll start by trying to introduce these two basic rules. So the simple exponential rule is of the form the integral of I presume that we know that a is that natural number, so we have the integral of exponential e raised to the power x dx is given as ex plus c. Now this is the simple exponential rule. This is the simple exponential rule, and then too we are going to have the general exponential rule. So basically for the general exponential rule, it's given as the integral of e to the power u du over dx, then dx, which basically is going to give the integral of a u du, which is a u plus c. So this, in comparison with that, of course, we're going to use the two different forms in trying to solve our problems. So basically I'm going to put them so that we can be able to reference or refer to them in solving our problems. So I'm going to just write them somewhere here. So first we have the simple exponential rule. Simple exponential rule. This is the first one I've said is the integral of ex dx equals ex plus c. And then this is the first one, and the general exponential is the integral of au du over dx equals the integral of au du, which of course we have said is equals au plus c. So therefore those are the two specific rules that we're going to apply in our sample questions, so that we are able to understand on how they can be able to be used. So I'll start by applying it in sample question 1, in this case whereby we are required to find the integral of 2ex dx. So in this case we're going to use the first, which is a simple exponential rule. Now that we know the exponent or the coefficient 2 is a constant, we're going to have it as 2 the integral of ex dx, and then this is going to give us ax plus c. So that's the answer to that one. But remember we have this coefficient here that is 2, so that's going to be the answer for that using the simple exponential rule. Now suppose we have an integral of this form, which is the integral of 2e2x dx. Then in this case we're going to use a different strategy. Now the solution is going to be, we let u be 2x, and we're going to see that finding dx du dx is equals 2, implying dx is equals du over 2. Therefore we are going to do a substitution for dx in that respect. So we shall have this form of an integral written as 2e Now for the sake of du dx, then we will do a substitution and write du over 2. So this one will cancel with that, and we will have a form of the equation with a form of the exponent that is au du. Now in this case, of course, we have written under the general exponential rule that this part or this kind of a function can be solved by just finding the answer to be eu plus c. But remember, we have done a substitution for u to be 2x, so therefore we are going to retain that one and write 2 2x plus c. So this is going to be the answer to the question, of course, which assumes that form of an integral. So that's our first sample question. Now let's look at another different sample question that is going to contain a different function, and try to see how that one can be handled as well. So suppose we are required to find the integral of a function that is the sine of x e the cosine of x dx. So in this case also we're going to choose one of the parts of the function and do a substitution. In this case we'll take the cosine of x and say let the cosine of x be u. Therefore this integral will be written as the sine of x au. Now in that case we know that this dx, of course, we can find it from the basic procedure that we have used for the first, of course, example. Therefore we shall have du over dx as, now integrating that trigonometric function, we're going to have it as the sine of x, the differential of the cosine of x, we're going to have it as sine of x. Therefore we find that this dx is the same as du over the sine of x. So therefore, doing a substitution for this, we shall have this integral written as the sine of x au, do a substitution for that, du over the sine of x. So for this case, the two parts of the integral which are similar, we will just simplify, and then we'll have this one as the integral of eu du, which is of the form of the general exponent that we have used before. So this one will give us the answer to be eu plus c. So therefore we have done a substitution for the cosine of the cosine of x to be u. Therefore we will retain it and write e the cosine of x plus c, which will be an integral, or the answer to the integral that we have given. So we're going to look at our last example and try to see whether the same rules apply. So I'll do away with this. We'll look at another sample question and try to see whether the same rules apply. So we have the integral over e3x plus 1 dx. So in this case as well, we use our strategy. This is the solution. Therefore, we will say let u, or let 3x plus 1 be u. Therefore, the u over dx is equals, this is going to be 3. So therefore, or implying dx is equals du over 3. So if we try to do a substitution for that, implying our integral will be written as e u du over 3. So this, of course, is going to use 3 as an coefficient. So we have 1 over 3, the integral of eu du. And of course, we are going to use the general exponential rule to find a solution for that. And that one will give us, this is a third e u plus c. So we have done a substitution for that one. Therefore, our answer will be a third e 3x plus 1 plus c. So using those two basic rules of trying to find the integrals of exponential functions, this is the procedure that we are going to use, of course, in finding integrals of similar form, and it's going to assist us, of course, in trying to solve problems that appear with the same format. So in that case, of course, that's the end of it. So thank you guys for watching, and I'd like to request those of us who have not subscribed to our YouTube channel, go to YouTube, search Sciences and Mathematics, or at best LTH 6110, and subscribe to our channel, of course, and be active on the comment section so that we can assist one another. I know that these discussions are not comprehensive, of course. There might be one of us who has something to add so that we can make it better and more interesting. So thank you. God bless you. Bye.